Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and New Relic. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. So let's get started. So the first thing we should understand and one terminology, and that is called observability, right? So the question is, what is observability? So I know that you have joined this session to learn monitoring tool, and to be specific, one Datadog. But Datadog is not a monitoring tool anymore. I said anymore. So Datadog is become observability platform. New Relic also has become an observability platform. Splunk also has become observability platform. ELK also has become a observability platform. AppDynamics, Dynatrace, all this thing has become a observability platform. So once every tool is becoming observability platform, then we should try to know what is observability. Correct? All of you? What do you think? Guys, please involve in the discussion. That's important. So, anyone have heard about it, observability before? All of you?
Yes.
Okay. So, what do you think? What is observability?
So it's kind of alert profile, their threshold configuration, visualization. So the groups of some monitoring features. So
Hmm.
we call it as observability. Yeah. So dashboard creations, alert management. Yeah.
Hmm. Yep. So, yeah, let's understand this. So, look at this. If you want to make any product reliable, okay, these are the at a high level. These are the things we do. We have a product, then development, then we do the capacity planning. We have a certain testing and plus release procedures, post-mortem root cause analysis, incident response process, and then monitoring. So monitoring is the basic component in their reliability pyramid and enable incident response and post-mortem. So this is something which we do. Monitoring is not something new, which is there from last 30 years. And we all understand that what is a monitoring. But monitoring is dead. Yes, monitoring is dead. And now we have observability. So long live observability. So the question again coming back to this, what is observability? So monitoring tells you whether the system is working or not. Okay, CPU is more or less, memory is more or less, disk space is more or less. If it is more alert, something like that. But here, observability lets you ask why is not working, why the CPU is going up, why the CPU is going down, utilization of CPU or RAM or disk or whatever it is. So observability will give you a little bit different metrics altogether. When you want to implement the observability, then you have to assemble all the fragments from where? All the logs of the systems and setup and monitoring tools and organize them in a such a way so you will get actionable knowledge out of it. Okay, actionable knowledge. That means in order to make the system observable, get all the data and then create that, use that data to create certain things which can be knowledgeable, which can create some uh, action knowledge, which can share some, which can create some knowledge where on which you can take up action. So once upon a time there was monitoring, whereas observability is a superset of monitoring. So that means monitoring is subset, observability is superset. Observability is a superset of monitoring. It provides not only a high level overview of system health, but also highly granular insight into implicit failure mode of the system. In addition, an observable system furnishes ample context about inner working, mind it, inner working. Through the monitoring, you don't get a inner working of your software and the behavior. But here, when you set up observability, you get inner working, unlocking the ability to uncover deeper systematic issues. Monitoring, on the other hand, is best suited to report the overall health of the system and to derive alerts. So look at this here. This is the monitoring, proactive, observability, reactive. So here, monitoring, which has alerting and overview, but observability, we have a debugging, profiling, dependency analysis, and anticipating for the future. Now, if you want to set up a monitor observability, then what to do? Of course, you have to do the monitoring, which will help you to get the predictable failures. But also, if you are from testing team, then probably you'll visualize that all the testing efforts, all the testing, automated testing efforts, you can incorporate, okay, all the best effort verification of correctness, you can incorporate it, all the predictable failures you can incorporate it and come up with the best effort simulation of failure mode of your application, and that is observability. So here in observability you are trying to get the best practices which you perform in testing to check the product reliability, availability and all stuff like that, so that you can also combine. So monitoring system should address two questions: what's broken and why broken. While observability cover a larger scope, monitoring is mainly used in the terms of metrics monitoring. In summary, observability is a property of system. Monitoring is an activity we perform on a system. Look at this here. This is the hierarchy of observability. So if you in observability you have to get the data from the past, such as tracing and logging, data from the present, such as matrices, and then based on the matrices tracing and logging, stats and signal using that you can predict. So past data you can use for diagnosed, present data you can display on the screen, dashboard, and prediction which can use for the detection. So this is the hierarchies of observability. So here are some of the more difference between the observability and monitoring. So observability helps you to gain understanding actively, monitoring which consume information passively. Observability ask a question based on hypothesis, whereas monitoring ask a question based on dashboard. This is very important. Third one, observability built to tame dynamic environment with changing complexity. Monitoring built to maintain static environment with little variation. Observability preferred by developer of system with Variability unknown permutations, monitoring used by developer of system with little change on non permutations. So here, can you please tell me what is a dynamic environment which is good for observability and what is static environment which we've been doing for monitoring? What do you think? Can you please tell me?
It's kind of proactive and reactive.
Yeah. So here I'm discussing about the dynamic environment and static environment. So my question is how what is a dynamic environment and what is a static environment, which is we were doing monitoring earlier on static environment. All of you.
I mean, dynamic means it will create a automatic play, right? By using.
Hmm. So guys, monitoring a static environment, that means VM's world. So what do you do in order to run a software? What do? You go to a cloud, create virtual servers, and then run that. The static IP address of those servers are fixed. You know that IP address of that VMs is fixed. You know that. So that monitoring those IP addresses become very easy actually. Now those environment is fixed, IP address are fixed. So you know what to monitor it. But whereas now if you talk about the dynamic environment such as Kubernetes, Docker, pods, you know that pods, correct? All of you have idea about the Kubernetes, right?
Yes.
Yeah.
So Kubernetes, you know that pods IP address changes because pods is not static. You increase decrease the replica sets, and then number of pods will get disappear appear. IP address will new IP address will come. So it always changing the environment. So how do you handle it where the IP address is changing every day or every week? How do you handle this kind of environment? And you're not running one or two pod, thousands of pod you're running it. So how do you monitor, how do we observe this dynamic environment in Kubernetes? So that is what observability is meant for it. So observability will help you in that case. So yeah, observability focuses on metrics, tracing and logs, and monitoring focuses on availability, performances and capacity. So now the question is, how do you perform observability? That is a question. So, in order to perform the observability, you need to gather the telemetry data. What is the telemetry data? The data which you can collect from the remote location and process it for getting some knowledge out of your system. So that's what telemetry data. So in simple way, if I put it up, if someone will ask you, hey, how can I set up observability? So you can simply say, hey, get the data first, and that is melt data. Melt for M for metrics, E for event, L for logs and traces. So these four data you need to collect, store it, explore it, and create a dashboard and alerts based on that. And then you should be able to create a observability set of observability for your project. Okay, so that is logs and events, put it in one go, one bucket. That's called melt. So yeah, three pillars of observability: collect the metrics as much you can, collect the traces, and the last one, logs. And if you collect these three, you are trying to set up observability. That means any problems you have in infrastructure, you have a complete detailed about it, all the matrices, traces, and logs. Okay. So now, what is a trace? What is a matrices, and what is a logs? So trace, we understand that which is a relationship between the two events. For example, I will hit the www.amazon.com and I would like to know how many seconds, or maybe Amazon would like to know how many seconds it took for getting a response for me. So that's a trace. Response time is a one trace actually. I hit to Amazon.com, Amazon.com hit to some other services, some other services hit to some other services, and this is a trace actually between the two endpoints, right? Matrices, I think you will understand more easier because this is something which we've been doing in the world of monitoring. So collecting CPU data, RAM data, storage, network, throughput, error rate, request durations, and all this stuff. You can talk about the matrices. Logs, I don't think so. I have to tell you. You have an infrastructure log, system log, application log, network logs, and all stuff like that. So metrics, which is measurement of an event, any event which occurs, you have a measurement for it. Okay, and logs, which is human readable events, and so on. So if you want to set up observability, you have to gather all these types of data. Are you understanding all of you?
Yes, Raj.
Yes. Yes.
Yeah. So observability means logging plus monitoring plus tracing plus visualizations. So some more factors if you want to understand in this context. Monitoring, if you're setting up a monitoring which you've been doing from last 20 30 years, you will set up availability and you'll get an answer whether it's my system is available or not. But observability will you will get to know how long is my system up. Performance in terms of monitoring, is my system healthy, and observability will give you that information what is my system doing. Fault management, when and where it did occur, but observability will let you know why did it occur, and recovery also. So some differentiating factor which is between the monitoring and observability. So we have discussed, if you want the system to be observable, you want to have information about the system inner and outer, then you have to collect the four types of data, which matrices, traces, logs, health check, and stuff like that. So these are the things you have to do that. So health check, in simple way, if I put it up, you can say synthetic testing. Okay, metrics, infrastructure, logs, and traces, which is we call it APM or rum. So I'll talk about one by one each and everything slowly. So more or less we understand the what is a metrics. So I'll not complicate more this discussion. Okay. So CPU, RAM, hard disk, throughput, success rate, error rate, performance rate, which you can measure it, that's a metrics. Okay, different types of metrics we have, and so on. Logs, we understand that. Traces, we understand that. Again, we'll discuss in detail what is a trace and what is a log in upcoming topics. Okay, so now next question is why the observability is very hard to do, and the reasons are very simple. Look at the environment what we are changing. So earlier we were running the applications in virtual servers. Now we are running the pod with Kubernetes. So this is the changes. Earlier we had a 2030 system. Now we have 5,000 pods like that. Not only the infrastructure is been changing, we have architecture also has changed. Earlier our softwares were monolithic. Every features you can find in the only one software. So setting up monitoring was very easy. Then we migrated to SOA and now microservices. Look at this microservices now. One software we have a 200 microservices, and each microservices is having different features, different databases, different things to monitor. This is the microservices. Look at this design of microservices. This is the wonderful image. It's a early image of Uber. Look at this. These are the microservices. Latest image is more complicated. So you need to set up observability for all these microservices, and you see that each microservice is talking to a number of other microservices, and so on. The current one will be more complicated. If you go for current one, if you see that here, Uber microservices, the image which I showed you is little older one actually, and this is the one. Just imagine you have to set up a monitoring for this one. So it's getting complicated day by days, right? What do you think, all of you? Hello? Yeah. So you have to, monitoring will not work in this. We have to make the system observable. So what you want? Do you want to know application availability? Is it up or not? Do you want to know application performance? Is it slow? Do you want to know application reliability? Is it broken? And same goes with the network availability, network performance, network reliability, server availability, server performance, and server reliability. And for all this, you can use any of these tools which you have. So yes, Datadog, we have Neuralink, we have Splunk, we have Elastic, we have App Dynamics, we have Dynatrace, we have Grafana. All these tools will help you to get you the observability setup done for your project. Not all tools has a capability. Out of which today I'll be teaching you Datadog.
If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.